And so with this video, what we're going to do is we're going to be trying to find a point at which a tangent line has a specific slope. So what they're giving us is they got this function y is equal to x squared, and they're telling us that we want to find the point that has a tangent line with a slope of 6. Right? So what we're going to have to do is we don't know how to take derivatives just yet. We're going to use something instead. We're going to find the slope of two separate points. So it's going to really be a secant line. Right? So the way we're going to start this out is by getting an original point. Now, the original point is going to be some sort of x value, which means my y value is going to be found by taking my x value and squaring it. That's what my function says. To find y equals, take your x value and square it, x squared. Right? Now, the other part is we're going to have to find a second point. So I just found my first point. To create a second point, we need to find a second x value. So what we're going to do is we're going to add some sort of distance to my original x value. So we're going to call that x plus h. Now, if my x value changed, that also means that my y value is going to change at the exact same time. So instead of it being x squared, it now becomes x plus h squared. Now, one thing that I'm going to have to do, because these are 2 points and we're going to find the slope between these 2 points, I need to FOIL out and multiply out the x plus h squared. That ends up getting me x squared plus 2xh plus h squared. All right, so now the next part, this is the calculus piece, is we are going to find the slope of our secant line. But in order for this secant line to turn into a tangent line, the distance, the h value, that we added to our original point needs to close and get closer and closer to 0. So the way we can do that is by taking a limit. So the limit as h approaches 0 of our secant slope. That's going to get us to our tangent line, right? So let's go ahead and actually find the slope of our secant line. So we're going to take our second y value, which is x squared plus 2xh plus h squared, and we're going to subtract our first y value, which was x squared. Now I'm going to divide that by my second x value, all subtracted by my first x value. So all I'm going to start to do right now is I'm going to start to cancel out some stuff. The x squareds are gone, the x's are gone. All right? So now what I'm left with is the limit, as h approaches 0, of 2xh plus h squared all over h. I'm going to do some canceling out again. Each of these terms has an h, so get rid of it. All right, so now what I'm left with is the limit as h approaches 0 of 2x plus h. Now, remember, the h value, the distance that we created for that second point, is getting closer and closer to 0, so our 2 points are becoming 1. All right, so this h value is actually going to go towards 0, so what we're left with now is just 2x. So this 2x, what that represents is a way to find every single slope of every single point on my curve, every single tangent line. So that's what we're going to do next, right? So as I said, our slope was 6, and 2x is how you find all slopes, all slope values. Now that's all slope values of tangent lines. So if I want to figure out where does this slope occur, I'm going to take how I find my slopes, 2x, and set it equal to the slope that I know, which is 6. So that means x equals 3. All right, so now what I have is an x value for a point. All I have to do is find my y value. So the function was y equals x squared. I'm going to go ahead and plug in my x value and get y equals 9. All right, so what this now tells me is that at this point, at the point 3, 9, we have a tangent line slope that is equal to 6. So at the point 3, 9, the slope of the tangent line is 6.